Hello everyone, Assalamu alaikum. This is Shafiq Mahmood from the Department of Urban and Regional Planning, SHUET. So today we are gonna see some interesting stuff. Like we all have those of us who are working in the GIS and remote sensing fields, we all have calculated several assessments like susceptibility map or vulnerability map or risk assessment. So we often have to find a few factors or a few determinants that actually determine the or provoke the whole assessment. So they're like elevation, slope, or LUSC like land use land cover or NDVI or aspect, curvature, or like drainage density, distance to road, or distance to river. So amongst all these factors, and after and we actually weight all these factors uh, based on the influence that they're actually putting in the assessment. So we can solve these like using different techniques, like using analytical hierarchy process, which is often known as AHP, or using machine learning. This is actually really common nowadays. So, but for the common thing is no matter what sort of technique we are using to assess, but the common thing is we all have to find these factors. So, what we are actually gonna watch today, that is, uh, we are talking about three of these factors. Like if we talk about the elevation, the direct data is actually we can assess that we can actually find directly the data from either from the USGS or from the Google Earth Engine. So from Google Earth Engine we can actually find most of the data. So like elevation, slope aspect. So these are really easy to find out. But there are there are three factors that cannot be found out directly from Google Earth Engine or somewhere else. So we must calculate that in the GIS tools like ArcGIS Pro or ArcMap. So we are actually gonna see this or how to calculate. We're actually gonna see how to calculate these three factors today. So let's start with the drainage density. For calculating drainage density, we'll have to calculate that from the elevation data or elevation map. So here actually I have selected a study area that is the greater Noakhali, like the Noakhali, Feni, and Lokipur. This is the study area I have selected. So and so I have actually you'll have to firstly you'll have to prepare the data. Like for drainage density, you'll have to calculate the find the take the elevation data, and from the elevation data we'll find the stream network, and from that stream network we can actually assess two of the factors like the drainage density and the distance to river. And for the calculating distance to road, we have to actually manage a road network or road shapefile. So here I have taken a shapefile of road in this region. So, and from that road network, I can calculate another factor, and that is the distance to road. So let's start with the drainage density first. We have the elevation map, and what should we do? Well, from elevation map, we actually, those who have worked regarding watershed delineation map or watershed analysis, we know that from elevation we can actually assess the stream network. So what's that process? So we'll have to, here's our geoprocessing search box. So first of all, we need to fill, the elevation data so that the depressions get filled actually. So let's just okay. One thing I should mention at first, like what let's just have a brief, like what is drainage density, right? So drainage density is actually the amount of drainage that is actually in 1 kilometer or 1 unit meter, right? So this is actually a density. There is no unit, particularly there is no unit. It is actually a ratio. Like it shows the percentage of the drainage that is actually existed in a particular region. So for like and if we talk about the distance to road, or distance to density, distance from road, or distance from river, or distance to road, so these all have like unit, like these are like length or the distance from a particular point, like a particular road or particular river. So if we want to calculate the distance, so we'll have to definitely have to show some unit. And if our map is not projected, we cannot assess the we cannot assess the unit properly. Like you guys can see in ArcGIS Pro, this is really cool that we can actually get to know if our map is projected or not. Like we can see this is not a projected coordinate, this is not a projected map. This is like the general WGS 1984. eh, so what you can do is you can just go to properties, and then we can just go to coordinate system. Like you can see the current coordinate is WGS 1984, and what we'll have to do is we should convert this in the 19 WGS 1984 UTM zone 46 north. So this is the perfect coordinate projected coordinate system for my location. So I'm gonna just click OK, and now you guys can see a change in the map. Like, have you noticed? Have you noticed the curves over here? So this is the change that actually occurs, that actually appears in the ArcGIS Pro interface when we are working regarding the projected coordinate system. So this is actually a really interesting, cool stuff that we actually not often see in the ArcMap. So that's why I've actually started using ArcGIS Pro. So this is really cool. Anyway, so now actually I can, so first of all you need to project the coordinate, project the map. So and then you'll have to start uh, all the processes that we are gonna find out. Let's see. First of all, we need to fill the elevation map. All right. So let's just run the process. All right. So I have found field dem data or elevation data. So now from the field, you'll have to go for the flow direction. So these are like all know that, I guess. Like these are really common. We are doing this for so long. I'm not changing anything over here. Let's just click OK. So yeah, once the flow direction is done, you guys can see you can change the symbology over here. Like I can change it to a stretch from the unique values. Okay, so I've just stretched this. Okay, so you have seen the flow direction, and now we'll have to find out the flow accumulation. I have another video, I guess, in this channel, which is titled Model Builder. So in that video, I guess I have discussed in much more explanatory way regarding these watershed delineation, or regarding these steps like fill, flow direction, flow accumulation. If you feel interested, you can just check that video out. But that video is in Bangla, so the foreign subscribers or the foreign viewers who are watching this from abroad, or who are not familiar to Bengali, you will find some problem, I guess, with the language. Anyway, so after that, we'll have to go for flow accumulation. Input flow direction raster. Input weight raster. I'm just gonna keep this as it is. So here is flow accumulation. Yeah, we have found out the flow accumulation and see we are here we're watching that there are 90 almost or 9 lakhs 3,977. So it's a huge number, right? So what we'll have to do is we'll have to put some condition like uh, we don't actually need the values which are really close to zero. So we'll have to just take the large streams. So that's why we'll put some condition like for putting condition as this is a raster file, we'll go to raster calculator. There are two softwares, like one is image analyst, one is spatial analyst. I guess I should go for this one. Anyway, so flow accumulation, and all right. So I'll go for the values that are more than I guess 10,000. Why am I putting 10,000? Because I guess uh, we should actually keep the values between 0.1% to 1% or 2%. This is the ideal way actually for putting condition. So as there is 9 lakhs, so I've just given here 10,000. So let's see what's the result. All right, I guess the result is satisfactory. We have actually found out the streamlines. So now what we'll have to do is we'll have to convert this into polylines. So you guys can see the lines, right? The streamlines, but these are raster values. So I'll have to put this in, I'll have to convert this in polylines. Let's see. Uh, there might be a tool called raster to polyline. Yes. So this is the where you should go for the raster file, and it will eventually give us a polyline feature. Raster full accumulation. Okay, let's just keep it simple. Anyway, so just yeah. So you guys can see now that I have actually found out that let's just uncheck the previous fields. Uh, all right. So now you guys can see that I've found out a really nice stream network. So it came really smooth. Anyway, so now what we will have to do is I can just let's just check the study area box shape file. And now we are done with our stream network. And now we'll have to calculate, we can calculate two factors from these streamlines. One is drainage density and the other one is the distance to river. So first of all, go for the drainage density. So for drainage density, for calculating drainage density, there is a tool called line density. So I can just the polyline feature. So the polyline feature is this. So this is it. So I don't need anything else, but I'll have to set up the environment over here, like the current map or processing extent. The processing extent should be the study area, otherwise it will go all over here and that will look really bad. And also I'll have to mask. So now the whole thing will be inside the study area shape file of mine. Anyway, so I can choose the square area units, like in what in how much area it will get calculated for. But I have told you before, like there is no particular unit for the drainage density because this is a ratio. But how much? But the but the upper part of, or what we can see, the nominator or denominator, I guess this is the term. So these will be in the square kilometers. I guess it means that. Anyway, so let's go for the run button. This actually came really small. It if we oh, let's just give this square meter. See, let's see if it gets changed or it remains as it is. Okay, all right, it remains as it is, but you guys can see that they are actually, if we actually have taken a much more dense streamline, like it would have come more, in more natural, in more beautiful visual. We would have got a more beautiful visual. And right now there are so many blank space over here, and that doesn't look really cool. So, but this is it. This is the process. Personally, I don't find it really beautiful. That's why I'm stammering right now. But this is the ideal process, and this is the drainage density for this streamline. But if we take a much more dense streamline, we'll have the drainage density dense as well. So and um, that time it will look much more what should I say, much more filled, or more dense, or much more, it will be full of beautification. So anyway, so this is the process to calculate drainage density. Anyway, so now what we can assess is distance to river. So this is the same thing. So I can just rename the file called drainage density, drainage density. So all right, and I can just give this a name called streamline. Anyway, so now what I can do is, for measuring any sort of distance, like either it is from distance to road or it is from distance to river, or for the earthquake analysis, we have often have to find distance from fault line. So any sort of distance we're calculating, will only need to go for the Euclidean distance rule. This is the tool, Euclidean distance. So we'll have to put this polyline feature over here, and then input raster feature barrier data, and the barrier data is our study area, and we'll have to put the coordinates as well over here, and we'll have to put the processing extent and mask. So the mask, it will also be my study area. I guess we are done. So there is this output cell size that you can see. So often you guys can convert this, or rate this your preferred output cell size over here, or you guys can see, or you guys can also change it afterwards with the tool called project raster. So I'm not changing anything right now. So if you need that, you can check that out, or you can do that afterwards. Anyway, so I can just click the run button right now. Uh, all right, so we actually did not get the output. So for that, I guess I have uh, calculated something wrong in the steps. Like, yeah, so this is not actually barrier data. This is actually a barrier data. This is not the processing extent or mask. So we'll have to keep it blank. Um, we'll just mask in this section. So in the environments, we'll have to set up like that, that the our outputs doesn't get out of the our desired study area. So I guess right now, if we just keep this area blank, I guess this will work. This should work. So I'm click the run button again. And yes, right now we've actually got our desired output. So if we just uncheck the streamline, so we can see a beautiful map of our distance to river. So I can just rename this, sorry, distance to river. All right, so we can see that there are 16,994 meters. These are in meters because our uh, map is projected in meters. So this is why we'll have to always project the map in at the first place. So otherwise these values are going to be absurd, or our calculation won't be really fruitful. So so our two of the factors are done, and lastly we'll have to go for another one, and this will also be calculated through uh, the Euclidean distance tool, and that is drainage distance to road. So we have the distance to road, and I found this actually from like I don't know, OpenStreetMap or somewhere else. For you guys can check multiple websites out to find these shape files, or you can just create your own. You guys can see create the shape files just looking at the base map. So there are multiple sort of base maps, and those can be assessed from. You can just change the base map from here, and if you just uh, go for the street map, and then you guys can create road shape files just by just looking at the base map. Anyway, so let's just start with our process, and now we can just right now we know what we'll have to do. We can just fix the coordinate over here. We'll just select the coordinate processing extent, and then we'll have to mask with our study area. Sorry. All right. So I guess we are done. And if we just click the run button right now, we should get a really smooth distance to road map. So you guys can see a really dense network over here. Like as our road shape file is really dense, so the map didn't came out really cool. So anyway, but the how much cool is that? That is not the question. So our procedure is right. So this is the actually the ideal way, and this is what came out is perfectly fine in terms of statistics. So there's no problem with that. So I'll just read them. it distance to road. So that's it. So these are the three things that I wanted to show you today, like the distance to road, distance to river, and the drainage density. So these are often calculated in several geospatial analysis for assessing several geospatial analysis like flood susceptibility, landslide susceptibility, or earthquake vulnerability, or many things, or many there are many sort of assessments that these factors are getting used from. So I guess you have found this video really helpful. If you do, please uh, hit the like button, and you can just appreciate me in the comment section. So I am still a learner, and I try to just share what I'm learning, and I want to make you a partner with my learning journey. So that's it. I'll be back with another video someday. So till then, just practice GIS, and Allah Hafiz.